Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 1 of our unit Mechanical Properties of Solids. So let's begin with today's class. In today's class, it is the introductory section of Mechanical Properties of Solids. So let's begin. when we say when we say mechanical property of solids, if we go to the very detail and minute level and very basic level, then we can say that physics is a branch of science which deals with the study of, we are going to study two parts. One is the energy, another is the matter. When we discuss the physics, when we say energy, it is the capacity to do work, and when we say matter, it is anything in this universe which has mass and occupies a space that we call as a matter. The work, power, energy, and all that units have studies related to energy. We have not studied matter anywhere up till now. So let's start it with a topic related to a matter. This is what we have completed and this is what we have learned up till now. So now the question is we have four different states. One is the solid, another is the liquid, other is the gases, and the one more it's a plasma. In this unit I'm going to find out the answer of this question. It's a what is a solid. So if I want to define it, just it is the solid is a state of matter in which its constituent atoms or molecules are held strongly at the position of minimum potential energy, and it has a definite shape and volume. You definitely know this, that what is solid, that it is a one of the matter which is having a definite shape and its volume, and its constituent atoms or molecules are held so strongly at the position of minimum potential energy, because we know that at the position of minimum potential energy it is in a stable state. We have studied the equilibrium and its correspondence with the potential energy. Now we came to know that at minimum potential energy, particle or a solid body or an object is in a state of stable equilibrium, while in the case of or in the state of the maximum potential energy, it will be at unstable equilibrium. I hope this is clear. Is it clear? Great. So so let's look at this. When a force is applied to a body, there are two possibilities. Look at this. We have an object and we have applied two forces. We have applied this, that one of the situation is like this, and we have applied a force from here and here. Both the sides you are pulling this rubber band, and this is the another situation where another object is there and you just squeeze it. So when we apply a force to a body, there are two possibilities. First, either state of the body changes, or the second one would be the shape or size of the body changes. So state of the body changes, that means the state of rest becomes state of motion. And let's say if shape or size of the body changes, then that change is known as the deformation, and the corresponding force which is deforming a body, which is going to change the shape or size of an object, that force is known as the deforming force. A deformation can be change in length, or it could be a change in volume, or it could be a change in shape. I hope this is clear. So when you apply a certain kind of force changes or try to changes which changes or try to changes the shape and size of an body, that is known as the deforming force. Please notate this and keep this in mind. Now, on the basis of the deformation, all bodies can be classified as follows. When we receive that different types of bodies are there, and then that could be a two types of body. One is the rigid body, another is the non-rigid body. When I say it's a non-rigid body, We have two options, either it would be an elastic body or it would be an plastic body. Either it would be an elastic body or it would be an plastic body. So let's begin with what is rigid body, what it is. When I say rigid body, in reality, if I understand it strictly, then no body is rigid. But for practical purpose, we assume a diamond or a steel sphere to be a perfectly rigid body. What does it mean that what rigid body is? We understand that rigid body generally means a hard solid object having definite shape and size, but in reality bodies can be stretched or compressed or bent. So even appreciably rigid steel sphere can be deformed when a sufficiently large external force is applied on it. This means that solid bodies are not perfectly rigid. So in reality, no bodies are said to be perfectly rigid. That means that if you apply a force, this body is not going to deform. Then that bodies are known as the rigid body. But if you apply a sufficiently large amount of force on anything, then there would be a change in shape or size, or it could bend it. But for practical purpose, for a certain kind of reference level, we understand that, and we consider the diamond and the steel sphere as the perfectly rigid body. So now, what is non-rigid body? What do we mean by non-rigid body? When we say non-rigid body, it is a body whose shape or size going to change if a very large amount of force is applied. So non-rigid body is a body whose shape or size changes if a very large amount of force is applied. Let's suppose a rubber band. Yes, it easily changes its shape. A steel or iron rod, yes, even it is going to change its shape or size. So this all are the non-rigid bodies. Now let's go inside the non-rigid body. We have two situations. Either it would be an elastic body containing elasticity, or either it would be an plastic body. It would be an plasti. It contains a plasticity. So what is elasticity? It is the property of a body by virtue of which it tends to regain its original size and shape after after the removal of deforming force. That is what we called as an elasticity. So let's say you need to understand this thing like this, that let's suppose this is a box, and let's suppose this is the L, and you are going to applying a force like this. I don't know which kind of force it is, but at this point of time I know only one force, which is a deforming force. So if I have applied a force, and as I have applied this force, a length of this box has been changed, let's say from this to this. So there is a change in there. But 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 if I remove the force, then it should again regain its original shape and size. Again it is having the length. If it is the case, then this body is said to be an elastic body, and this body is containing a property of elasticity, that after removal of deforming force, he it needs to regain its original shape and size. Then that is what we call as the elasticity. Example, it's a rubber. Yes, take a rubber band, stretch it from both the sides. You are applying force here, you are applying a force of here, and when you remove this force, you will understand that rubber band again easily, very easily regain its shape and size. Next, it's a plasticity. What is it? When I say plasticity, it is the property of a body by virtue of which it does not regain its original shape and size even after the removal of deforming force. That is what we call as a plasticity. Examples, let's take an example of clay or wax or a duff. This all are the bodies that, even though, let's suppose if wax is there, you have lit up the candle, and when you use it, even after this candle has been blown out, even if this candle is blown out, this wax is not going to arrange itself into its original shape. No, this is not the case. A same thing is clay. Once its shape has been changed, but if I'm going to remove the force, it is not going to regain its original shape and size. So this all bodies are the plus contains a property which we call as a plasticity. So what is perfect plastic body? A perfect plastic body, that means on the removal of deforming force, the body does not have any tendency to regain its original size and shape. If it is not going to regain its original shape and size, then it is said to be perfectly plastic. We have seen the examples. Practically, there is no material which is either perfectly elastic or perfectly plastic, and the behavior of the actual bodies lie between these two extremes. But before we understood anything, let's look at first what is perfect elastic body. What is it? So when I say perfect elastic body, it means on the removal of deforming force, the body regain its original size and shape. Then the body is said to be perfectly elastic. So if body is about to regain its original shape and size, then it's a perfect elastic body. If body is not going to regain its original shape and size, it is a plastic body. But as we have discussed here, that practically there is no material which is eitherly perfect plastic or perfect elastic. Generally the body lies between these two extreme ends. Yes, I hope this is clear. Now let's discuss what is internal restoring force. Let's look at this. This is a sponge pad. This is a sponge pad, and you are going to apply a force on this sponge pad. So when you are going to apply a force on this sponge pad, look at this. Its shape changes, but by some time, after some time, it is going to regain its original shape again on its own. When it regains its own, it is having certain kind of internal restoring force, which allows it to regain its own shape. Look at this. This is the different situation. This is even one of the material on which you are going to press the ball. When you are going to press the ball, this ball goes down. When this ball goes down, there is a change in the shape of the upper surface of this body. But as soon as some time passes, it again regain its original shape and ball will again go to in this direction. So this is the restoring force, what we call as this is the restoring force. This restoring force is not new to you. We have seen even in this case of a spring, that this is spring, and if I apply an F external on this, then when it has been stretched, let's suppose something like this is the case of F external, then F restoring developed in this direction. It is in the opposite to the d- direction of F external. So the force which brings the body to its original shape and size is called as the internal restoring force. For elastic body, the deforming force and restoring force would be the equal. But for the plastic force, deforming force must be greater than the restoring force, because in the plastic body, once you are going to apply a force, then it is not going to change in its own. Once you apply this deforming force, then this is not going to change itself, and that's why internal restoring force is very less, so that object cannot came back to its original shape and size. I hope this is clear. So let's just summarize what is elastic and what is plastic body. When I say what is a elastic body, it means body regains its original shape and or size after removal of force. In this, body does not regain its original shape or size even after removal of force. In the elastic body, there is a temporary deformation, but in the plastic body, it's a permanent deformation. In the elastic body, deforming force and restoring force would be the equal. In the plastic body, deforming force greater than must be greater than restoring force. In the elastic body, intermolecular forces are very large, but in this plastic body, intermolecular forces are very small, or generally they are not going to be present over there. A rubber coat or a metal like steel or a copper, aluminum, etc. Again, within elastic limit, because everything has a certain limitations. All this are known as the elastic body. Plastic body, it's a clay, wax, mud, duff, putty. All this are the case of the plastic body. I hope this is clear. Is it clear? Yes, no. Yes, are you sure? Yes, no. Great. We have very good statement. Please have a focus on this. It says that steel is more elastic than rubber. Steel is more elastic than rubber because when I apply a deforming force on the steel, when I apply a deforming force on the steel, steel will regain its original shape and size. It's a steel, yes. Steel will regain its original shape and size, but rubber, it is not going to regain, not always, not going to regain its shape and size after certain limits. So steel is more elastic. When I compare elasticity of steel and rubber, steel is more elastic than rubber. Please keep this in mind. Now let's look at certain quick questions. We said that when a body regain its original dimensions, when deforming force is removed, then this is called as the elastic body. I hope this is clear. What is plastic body? What is plastic body? That it does not it does not regain its original shape or size. It does not regain its original shape or size. Then this body is is plastic body. Yes. Next, the force due to which the dimension or size of a rigid body, the dimensions or size of a rigid body changes, is known as, yes, that is what we call as a deforming force, which which changes or which tries to changes the shape or size of an body. This is deforming force. Let's look at the next. The force which brings back a body into its original shape is known as the internal restoring force. Yes, it is the internal restoring force which tries to change the shape of an object, and which is always acting in the opposite direction of external force. So when it tries to change the body, it always tries to behave like my object should again regain its original shape and size. I hope this is clear. Next, in a perfect plastic body, the internal restoring force is in a perfect plastic body, internal restoring force is zero. That's why it cannot regain its original shape and size, and that's why it is known as the plastic body. I hope this is clear. Is it clear? Is it clear? So now let's discuss the elastic behavior of solids. So when I say elastic behavior of solids, the means is when a solid is going to be deformed, the atoms or molecules are displaced from their equilibrium position, causing a change in the interatomic or intermolecular distances. But when this deforming force is removed, the interatomic force tend to drive them back to their original position. If this happens that in, internal restoring force came into play, and again body is going to regain its original shape or size, then 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 this body is said as an elastic body. So let's look at this. What we have done is that this all are the atoms, and we have connect them with the springs. It's a basically a spring ball model of to understand the atom structure exactly. What we are supposed to do is, if I'm going to pull any one of the atom from this, let's suppose in this direction, then this connected springs will behave like that. This atom will came back to that position on its own. This is what we understood as an internal restoring force. And if it can regain its original shape and size, then this is perfectly elastic body. I hope this is clear. Is it clear? Yes. So the restoring mechanism can be visualized by taking, we have seen this restoring mechanism. I hope this is clear. This is the best model to understand the situation. I hope this is clear. Do you understand it? Have you? Have you got this? Are you sure? Great. So let's look at quick questions. It's the model of spring and ball system gives the blank behavior of the solids. Yes, they give the elastic behavior of the solids. Next, which of the following material which of the following material has the highest elasticity? Yes, steel is having highest elasticity. That's why we have said it's a elasticity of steel is greater than the elasticity of rubber. By virtue of the property of elasticity, a force of attraction exists between bodies. No. A body is in equilibrium. No. It occupies a minimum surface area. No. It opposes the deforming force. Yes. It opposes the deforming force. And that's why it can came back to its original shape or the size. Now let's discuss a very important parameter to understand the solids. We are going to learn three parameters one by one. One is the stress, another is the strain, and the third one will be the modulus. Yes, so it is just the first step towards understanding of the solids. And let's begin with the stress. What is stress? When we understand the stress, we say that when a deforming force is applied on a body, there will be relative displacement of the particles, and due to the property of elasticity, an internal restoring force is developed, which tends to regain the body to its original state. This restoring force per unit area of the cross section of the deformed body is what we call as a stress. This is stress. I hope this is clear. Is it clear? Is it? Are you sure? Do you understand this completely? Yes, that when a force is there, and we are going to apply a force on this. Let's suppose something like this, that this body is there. You are going to apply a force on this, and let's suppose a restoring force is developed. Then this restoring force divide by its cross sectional area, it's an internal restoring force divided by its cross sectional area, that is what we called as a stress. But we can apply even the force applied divided by area of cross section, because this internal restoring force and the force applied both are equal. Yes, because it's an elastic body, and when it is an elastic body, please do remember that deforming force, that means a force which tries to regain, which tries to change, sorry, which tries to change the shape and size of a body, will be equals to the same as the internal restoring force. Stress is defined as the internal restoring force per unit area. It's SI unit. Basically, it's a force per area, so it is a Newton per meter square. Dimensional formula, let's suppose this is force, it's in kg meter per second square, so it's m1 l1 t minus 2 divide by area. When I say the area, it's a meter square. So this is equals to m1 l minus 1 and t minus 2. The units and dimensions of stress are same as that of the pressure. The units and dimensions of the stress are same as that of the pressure. CGS unit of it, CGS unit of it, it's a dyne per centimeter square. It's a dyne per centimeter square. I hope this is clear. Is it clear? Is it clear? Great. Now, now let's understood different types of stress. There are two ways in which the solid changes its dimension when an external force is acting on it. One of them is the normal stress. One of them is the normal stress in which if this stress is normal, that means perpendicular to the surface, then it is called as the normal stress. The stress is always normal in the case of change in length or a body or a volume of a body. When I need to change the length of a body or volume of a body, it is always the normal stress. It will be always acting perpendicular to its surface. Another stress, it's a tangential or shearing stress. So let's look what is tangential or shearing stress, and but before that we will like to discuss what is normal stress. So when I say normal stress, even in normal stress there are two divisions. One is the longitudinal stress and another is the volume or bulk stress. So now let's understand what is longitudinal stress. We said that when a normal stress changes the length of a body, when a normal stress changes the length of a body, then it is called as the longitudinal stress. And this longitudinal stress could be said as the deforming force divided by area of cross section. So it is something again like this, it's a longitudinal. So this is the situation, this was the body. If I have applied a force that is perpendicular to the surface, then this force will try to change the change the length of a body, something like this. This is change. Then this force, this is the deforming force divided by unit area, is called as the longitudinal stress. I hope this is clear. Yes. So it can be longitudinal stress can be further divided into two types. They are the tensile stress and compressive stress. Now the question is, what is tensile stress? What is tensile stress? If a rod is stretched by two equal forces applied, which is normal to its cross sectional area, then the restoring force developed per unit area is known as the tensile stress. And what is compressive stress? What is it? When we say it's a compressive stress, we say that if a rod is compressed under the action of the applied force, the restoring force per unit area is called as the compressive stress. So there are basically two types of stress, tensile and compressive. I hope this is clear. Now let's understood that what is volume stress. No need to say anything. This is the situation that, let's suppose this is a body, and if this body is having a force from every dimension, then the new situation of this body would be something like this. This is this ratio, it's a delta v by v. That is what we understood as a volume stress. I hope this is clear. Is it clear? So basically a volume stress, it's a force by area. It is a force by area. This force is acting perpendicularly, as you can see it very easily. So any stress would be there. Any stress would be there. It is a ratio of force to the area. But here it's a perpendicular force that is acting. It's a perpendicular force that is acting on the body, and that's why we call this as a normal stresses. Next, next, let's look at this. Let's look at this. This is longitudinal stress or tensile stress. It is the original body. It's a Dr. X, and if you are going to punch him, then its shape changes. It is something like this. It's a longitudinal or tensile stress. This is the body. You are going to applying a force from here, and it is going to change its shape, something like this. So this is force by area, or I should say it's a perpendicular force per area, is what we call as a longitudinal stress or tensile stress. It will try to it will try to change the length of an object. I hope this is clear. Is it clear? Is it clear? So now let's look at formula wise what is volume stress. When a normal stress changes the volume of the body, then it is called as a volume stress. Let's look that if you are applying a force from every direction and equal amount of force is acting on the total body, then this volume stress is known as the applied force divided by area. But in reality, this is what we consider. We consider it as a change in the pressure itself. So when forces of equal magnitude act on a body which is normally from all the directions, then the volume of the body changes, and this change in volume leads to us understand what volume stress is. It's basically a ratio of the applied force to the area, and this applied force should be perpendicular to the surface area. Now let's look at the a second category of force, a second category of stress. Sorry, it is a shearing stress. This is an object, and you are going to apply a force from here. So basically, it's a parallel force acting on the surface, and due to this, its shape has been changed. Look at this. If you want to try it, if you can try this, that let's suppose this is your book, and if you are going to apply a force from here, or rather you can force apply it from here, anything, then this upper layer, you can see this upper layer has been shifted like this. Yes, this is the situation of the upper layer, and this would be the below layer. It would be a bottom layer. So when the deformation consists of a change in shape, this stress is known as the shearing stress. Here in the shearing stress, this applied tangential force, it is a parallel force divided by cross sectional area. It's a unit, again unit would be the same, it's a Newton per meter square. Dimensions would be the same as it was for the any stresses, but in the tangential, in the in the longitudinal stress, it is the force that is perpendicular acting. In the volume stress, in the volumetric stress, the force is acting perpendicularly. In the shearing stress, this force is acting parallel to the surface. I hope this is clear. Is it clear? Is it? Are you sure? Now, what is SI unit of stress? It's a Newton per meter square, because when I say it's a stress, it is basically a force divided by area. It's a force, that means Newton, it's an area, it would be a meter square. So it's a Newton per meter square. Next, the units of stress is same as that of the pressure. Yes, force by area, it's a unit of pressure also. So are you clear with the stress? Do you have any doubts up till now? Anything? No? Great. Now let's look a second important parameter, that is what we call as a strain. Now what is strain? What is strain? It is the ratio of the change produced in the dimensions of a body by system of forces or couples in equilibrium to its original dimension is called as the strain. So basically strain is, it's a change in dimension divided by original dimension. This is what we call as a strain. As you can understood that this is change in dimension, either it could be a change in length divided by original length. It would be either change in shape divide by original shape, or it could be a change in volume divided by original volume. If you can see any of this, if you can see this any of this, it is, if I understood this, or if I look at this based on the formula or based on the units or dimensional formula, then this is meter by meter, this is meter delta v, it's a meter cube by meter cube. So this strain is having no units, and if it is having no units, that means it is having no dimensions too. So I hope this is clear. Up till now you understand what strain is. Let's look types of the strain. Strain is classified into three types depending upon the changes produced in a body. These types of strain are the longitudinal strain, volume strain, and shearing strain. So basically three types of strains are there: longitudinal strain or volume strain or shearing strains are there. Let's understood first what longitudinal strain is. It is defined as the ratio of the change in length of a body to its original length. When I say it's a longitudinal strain, this would be equals to delta L by L. This delta L, this delta L is the change in length, while L, it is the original length. So in this case, what you are supposed to do is that this road is there, and you have attached one of the block here. When you have attached a block here, mg would be start acting on it, and when mg is going to acting, this is going to increase its length by amount delta L. So if the length increases due to tensile stresses, the corresponding strain is called as the tensile strain. So this is the tensile strain, or I should say it's a longitudinal strain. I hope this is clear. Is it clear? Great. Now, what is volumetric strain? It's a volume strain. If the ratio of the change in volume, it is the ratio of the change in volume of a body to its original volume. This is what we call as the volume strain. Let's suppose understood that V is the volume of a given body under the action of a normal stress, and suppose that change in the volume is the V, then volume strain, it's a delta V by V. So here delta V, it's a change in volume, and V is the original volume. So this is volumetric strain, it's a volume strain. Now let's look at this shearing strain. What happens in shearing strain is, it is the lateral displacement of any layer. Let's look that. Please do understand that we have applied a force over here, and this layer has been shifted to this. So this is the lateral displacement. This is the lateral displacement, or you can see it from here. So if you observe this situation looks something like this. This is theta, this is x, this is h. So it's a lateral displacement of any layer. Any layer was here, and that layer has been shifted to this. So it's a displacement divide by its perpendicular distance from the fixed layer. This is the fixed layer. So basically it's an x by h. From this figure you can also call this as a tan theta, because when angle is very small, this is approximately equals to theta, but this could be said it's a tan theta, that is equals to x by h. So basically it is the ratio of the displacement of any layer to the perpendicular distance from the fixed layer. That is what we call as a shearing stress. So I hope now you have done all three stresses. You have been covered all three stresses as well as three strains. One of them was the longitudinal strain, another is the shearing strain, and next is the volumetric strain. I hope this is clear. Is it clear? Is it? Are you sure? Do you have any doubts up till now? Is there anything? Do you have any doubts? Do you? No? Great. Now let's look at certain quick questions. Which one of the following physical quantities does not have the unit of force per unit area? A stress, again having a force per area. Young's modulus of elasticity, you will learn it later, but it is something like this. It's an F by A divided by delta L by L. So again delta L by L, it's a dimensionless F by A. Yes, again the having same unit as the force per unit area. Pressure, again it's a force per unit area. So my question is does not have. So this would be the correct option, because all this are having the same unit as that of the force per unit area. Next, it said that the change in the shape of a regular body is due to its change. When I say change, it's a shearing strain. It's a shearing strain. Shear means to change in the shape. I hope this is clear. Is it clear? Great. Next, two wires made of same material having lengths 1 is to 2. It's an L1 is to L2. This is equals to 1 is to 2. And equal area of cross section, that means A1 equals to A2, are stretched with equal force. It's an F1 is equals to F2. The strain, the strain produced in them, the strain produced in them are in the ratio of. So if I have been same material, it is something like this. You might have studied this. It's y is equals to F by A divided by delta L by L. They have been made up from the same material, so their Young's modulus are also equal. So this is F by A. This is equals to delta L by L. So when I say it's an F by A, when I say it's an F by F, I am looking for the delta L by L. So it's a delta L by L of first material divided by delta L by L of second material. This is force by unit area of first material divided by force by unit area of second material. Their forces are equal, their area would be equal, so this is 1 is to 1. If you don't understand it, don't worry. When we are going to cover this, you will automatically understood this. Yes? Great. Let's look at the next question. The resulting strain when a spring is stretched, it is going to change its shape, and when anything that changes the shape, it is the shear strain. I hope this is clear. Is it clear? Great. So let's wind up this session over here. We understood two very important parameters regarding the elasticity of the body. One was the stress, another is the strain. This unit is purely theoretical units. All the things, all the theories, and so much of theories has been covered in this unit. But this unit has a capability to produce one question for sure in your competitive examinations. But it is having, it may have produced a certain years two questions, and it is a very big thing. It's a very small unit with very limited amount of applications. So please go through this very carefully. Only 6 to 7 hours of your study can cover this unit in a very good manner. So please allot this time and make it done. Thank you. Have a good day. Take care. Bye.